Hi, we'd like to welcome you to another in a series of webinars designed for departments of transportation. I'm Terry Bills, and I'm the Transportation Industry Manager here at Esri, and today I'm joined by Magdy Mikhail from AgileAssets, a good partner of Esri's. Today's webinar is focused on the incorporation of GIS into pavement management and how the integration of GIS into AgileAssets Pavement Analyst can help agencies improve their overall pavement management strategies. Magdy will be drawing on his experience at TxDOT, where he was their pavement asset management director before he joined AgileAssets as a senior consultant, his current role. Obviously, this is an area of great interest to DOTs, since pavement is often the most valuable asset that DOTs manage and maintain. And as a result, most DOTs recognize the importance of good asset management practice in preserving their infrastructure. But that said, it's still an area where many DOTs still grapple with establishing good workflows and building effective systems to help them make better investment decisions. So in today's webinar, we hope to show you an example of what DOTs can achieve with a coordinated and strategic approach to pavement management. But before we begin, I'd like to point out that we are recording this webinar, and while everyone will be on mute, there will be time at the end for question and answers at the end of the presentation. So you can type your questions into the question box, and we'll try to answer as many as time allows. And additionally, the slides which are part of this webinar will be available to you on the GeoNet group, Departments of Transportation, and we can give you that link at the end of the webinar. So to start, let me state the obvious, that the goal of asset management is really the better management of our public infrastructure and the best ways to preserve the life of those public assets. As you'll hear from Magdy, based on his experience at TxDOT, GIS, together with a comprehensive pavement management solution, helps agencies assess their pavement condition, manage their pavement inventories, and ultimately to develop an optimized pavement management and pavement maintenance and rehabilitation plans. And such an approach really depends on having good data, good methods of analysis to assist the asset manager in making timely preservation decisions, which leads to the second main point of asset management, that we want to be able to plan for our maintenance expenditures and develop longer-term capital maintenance budgets to, in essence, to amortize the cost of maintenance into a regularized schedule. And most people know the last thing that elected officials want to see are budget requests that swing wildly, but rather they want to know the level of expenditure to maintain their road and highway assets at a given level of condition and performance. And finally, we want to be able to have a full accounting of our maintenance costs so that we can better understand our full life cycle costs. Maintenance activities typically consume as much as 70% of any project's full life cycle cost. So maintaining good maintenance data allows us to better understand total costs in the project planning stages. To say nothing of the fact that we can better manage our maintenance activities if we're carefully tracking our efforts. So one of the reasons why asset management has become so important for DOTs, at least in the US, is that it's really a required component of the MAP-21 and the FAST Acts. And these authorization bills require that every state DOT demonstrate that they've implemented a performance-based transportation asset management plan, a TAMP, to preserve and maintain their assets. And ultimately, the goal is, how do we move from reactive maintenance, which tends to be much more costly over the long run, to proactive and ultimately predict asset management and maintenance, predictive asset management and maintenance, so that we can greatly reduce the risk of failures and significantly reduce the life cycle costs of maintenance. And in fact, states are required to demonstrate that they have included a risk analysis in their overall asset management plans. But rather than me, why don't I turn it over to Magdy to discuss his practice in TxDOT. And Magdy, take it away.
Thank you, Terry. Hello, everyone. In my presentation today, I will show you some GIS map-based practices that TxDOT uses to manage its vast highway network very successfully and effectively. What I hope you will take away from my presentation is ideas for how your organization can use these same practices to improve or enhance your own pavement management practices. In this presentation, I'll briefly discuss why pavement management is critical for transportation agencies, cities, counties, and municipalities. I'll describe the role of integrated GIS maps, ways to use them to improve pavement management practices, and the benefits of using maps to get better results for your agency and your network. And at the end, we will welcome your questions. First, why is pavement management critical to the quality of our roadway systems? A look at some statistics from nationally published report shows that crumbling roadways are a costly challenge in the US. 44% of major US roads are in poor or mediocre condition. It will cost an estimated $2 trillion to fix them. But current funding covers only an estimated 50% of the needed repairs, which means we have a $1 trillion gap in funding. Effective pavement life cycle management addresses these challenges. When done right, pavement life cycle management enables agencies to maximize the budget. That means keeping as many roads as possible in safe, good condition using the available funds. Optimize asset life cycle. That means applying the right treatment to the right assets at the right time to get the most value from each asset across its entire life cycle. Meet national regulatory standards, federal requirements. These standards can vary by country, of course. In the US, good pavement management practices are effective in helping agencies meet the legislative requirements such as the FAST Act and meet the performance targets for the National Highway System, the NHS. And finally, effective pavement management helps agencies improve network performance. That means meeting the agency goals to increase safety, preserve assets, and improve overall condition with the specified budget. To give you an example of the economic impact of effective pavement life cycle management practices, spending $1 on road repairs saves an estimated $5.20 in future economic and environmental cost, because rough roads and roads in poor condition lead to more fuel consumption and cause more damage to passenger cars and trucks. So the right pavement management strategy is critical to get the most value from your infrastructure investment. In fact, to take an example from Texas DOT that spends more than $1 billion annually on pavement maintenance, preservation, and rehabilitation, saving just 1 to 2% annual through effective pavement life cycle management saves TxDOT $20 million to $40 million per year. When done well, the impact of pavement lifecycle management is to identify the best mix of projects to meet the multiple goals of any agency. Preservation. Pavement preservations are applied when the pavement is in relatively good or fair condition and typically cost much less than rehabilitation or replacement, and allows the agency to stretch the dollars by treating more lane miles. Rehabilitation. Pavement rehabilitation is typically done on pavements that are not in good condition and need more work to address some structural problems. Pavement rehabilitation always costs more than pavement preservation. Replacement or reconstruction is a pavement that's in a poor or very poor condition and is the most expensive option and costs more than preservation and rehabilitation. For example, maximizing network performance, maintaining the highest possible percentage of your network in state of good repair, giving your available budget. Optimize asset life cycle so you get the highest return on your infrastructure investments. Meet regulatory standards to qualify for federal funding and avoid penalties. And as always, make the most of your budget to deliver the highest quality road network from taxpayer dollars to the traveling public. Again, TxDOT provides an excellent example. For many years, they have collaborated with AgileAssets to implement advanced pavement management strategies and solutions. In the words of Dr. Jenny Lee, Director of the Pavement Preservation Branch at TxDOT, pavement management allows TxDOT to get the most value from available project resources by optimally allocating taxpayer dollars. And when we optimally allocate taxpayer dollars, we can focus on preservation as the preferred strategy when identifying the best mix of projects to meet the agency's multiple goals. Now, let's look at the role of integrated GIS maps in pavement management. When I say integrated, I'm referring to maps that you can generate directly within your pavement management system without having to import or export any files. TxDOT generates Esri ArcGIS maps directly within the AgileAssets Pavement Analyst solution. I will show you several examples of these maps throughout my presentation. But before we do that, let's clarify a few things about the role of integrated GIS. As a pavement management engineer or asset management professional, you can use maps to do three important things that add value to your agency. First, you can use maps to visualize many types of data, whether that's the inventory data or condition data or a combination. Second, you can use maps to support spatial analysis, so you can help turn that data into actionable insights. And third, you can use maps to facilitate project planning and reporting so that you make data-driven decisions more quickly and easily and communicate about these decisions more effectively. GIS maps are invaluable tools to communicate and share information in all three of these areas. I like to say that one map is worth 1,000 pages of a written or a tabular report. And a GIS map, just one page, can provide you with a lot of information. For example, a one-page map can show you the condition of every road in a county in half-mile increments. You can even compare the condition of different roads to know which are performing well and which are not, just by looking at the map. Or you could get the same information by printing hundreds of pages of tabular report and sifting through the data manually. Which would you rather do? And which do you think gives you a faster, more intuitive understanding of the facts? Which do you think helps you communicate these facts in a more compelling way? The maps, of course. Now, let's look at specific ways of using maps for pavement lifecycle management. I will show you examples from Texas DOT generated in the AgileAssets solution. But this example could apply to any road network of any size. A state like Texas DOT, a province like Quebec, a city like Raleigh, a county like Polk, a nation like Bina Marga in Indonesia, or an airport like Aramco in Saudi Arabia. In fact, dozens of agencies like these across the United States and worldwide have partnered with AgileAssets to use the same strategies and solution that TxDOT is using so successfully. So no matter the size of your transportation network, you can use these same practices to advance the pavement management practices of your organization. And I'll show you a few ways to do that. These map-based practices also can be used by roles at all levels of your organization: the chief engineer, district and engineering operations, district engineers, and directors of maintenance, all the way down to maintenance crews. So no matter what level in your organization, these practices I'm about to show you can add value across many roles. Now let's recall that a key role of a GIS map is to visualize many types of data. In the next several slides, I will provide examples of two key types of data visualization: inventory data and condition data. We'll begin with the inventory data. Some commonly used types of inventory data include pavement type, traffic classes, number of trucks per day, pavement surface width, and number of through lanes. These types of data are critical for decision-making and planning processes. Let's look a bit closer at pavement types. There are three broad types: flexible pavements, jointed concrete pavements, and continuously reinforced concrete pavement. The pavement type is important because it influences data collection and analysis. The agency will need to collect different categories of data and use different models and decision trees to analyze the data specific to each pavement type. Here, you see an example of a GIS map showing the broad pavement type for TxDOT's Austin District, which covers the greater metropolitan area of the state capital of Texas. The map shows that the majority of roads consist of flexible pavements, shown here in blue, while CRCP is used for very few major corridors, shown in red. The GIS map provides the user with a very quick and intuitive display of the pavement types. And in a matter of seconds, you can see exactly where the CRCP pavements are. Another type of inventory data is traffic classes, or the average daily traffic. This data is very important for highway design and is a critical factor in project selection and decisions. Here you see a GIS map showing the different traffic classes for the Forward District, which includes Tarrant County towards the east on the right-hand side of the map. Tarrant County is the biggest county in the district, and almost all its roads carry high traffic, as you can see from the red lines crisscrossing the map. Outside Tarrant County, towards the west or the left-hand side of the map, most of the roads carry low to medium traffic, except for few corridors. Again, the map provides a very quick visual display of the different traffic classes for all the roadways in the district. Truck traffic is a very crucial in pavement management because the damage to the pavement from one truck is equivalent to the damage from 10,000 vehicles. Here you see a GIS map of the truck traffic for the San Antonio district. As you can see, the I-35 carries a lot of truck traffic, as shown in the bright red line running from the lower left corner to the upper right-hand corner of the map. That's traffic on an interstate that stretches from Laredo, Texas, near the border with Mexico, all the way north to Minnesota. How convenient to be able to see the truck traffic immediately by looking at the map. GIS maps and tools also allow you to drill down to display the actual counts on the map, so you can easily see the exact number of trucks per day for every section. Surface width. Surface width is another type of data that's especially important when it comes to planning projects for widening of travel lanes. Surface width is also used to identify shoulder width, which is an important consideration for roadway safety, since shoulder width can directly impact safety and level of service. Here you see a map showing surface width for the Houston Metro District. From the red lines, you can quickly see that Houston has several sections greater than 68 feet. There are very few blue lines, which means very few sections less than 24 feet, and those are in the rural parts of the district, mostly on the left-hand side of the map. Number of through lanes is a very important factor in pavement design and also in estimating project costs. This map shows you the number of through lanes. As you can see, the major corridors and major routes in the center of the map have more through lanes shown in green and yellow than the outer parts of the district, where the fewer lanes are shown in blue. Condition data. Let's look at a different category of data, namely the condition data. First, let's define the scores that make up the condition score. Distress score is a function of the surface distresses and has a range from 0, which is very poor, to 100, which is very good. Similarly, the ride score is an indication of how smooth the pavement is. This serves as an indication of the quality of the ride. Anything lower than 1 is a very poor score, while anything between 4 and 5 is very good. A brand new pavement, depending on the construction and surface type, can be between 4.2 and 4.6. The condition score is a function of both the distress score and the ride score. Like the distress score, it ranges from 0, which is very poor, to 100, which is very good. Just to give you an idea of the vast amount of condition data, here is a list of the typical distresses on a flexible pavement, which is, as you remember, is just one of 3 main pavement types. You can imagine how the volume of data multiplies exponentially when you include multiple types of distresses for the other pavement types and so on. Imagine listing all this data in tables rather than displaying it quickly and easily on a map. This is the beauty of using integrated maps. In a few seconds, you can gain a lot of information by visualizing many types of data on the map. With that, we can move to the second important role of integrated GIS maps, which is support spatial data analysis. Through spatial analysis, we can filter the data in many different ways so we can understand it better and decide how to act on it. To analyze the data in a robust pavement management system, such as the one shown here, you can apply different filters to display different routes or specific features. For example, we filtered this map to show only the roadways that have a width less than 24 feet, as shown in dark blue. The filters can be applied for different values and different criteria. Here is another example of filtering to show roadways within the low traffic class with an average ADT between 1 and 27,500 ADT per day, vehicles per day. Those are shown again in dark blue. Or we can filter the map to show only the roads with 20% truck traffic. So the map displays sections in the medium and high traffic classes shown in green and red. These are the routes with more than 20% truck traffic. Surface age. We all know the age of our house to decide when to replace the roof or when to repaint the inside or outside of our house. Surface age is a very important attribute in managing the pavement. Surface age correlates to condition. Surface age is also critical for planning and programming preservation activities and is used in decision trees. This map shows a lot of dark blue, which are pavements with surface age 3 years old or less, and quite a lot of green, which shows surfaces 4 to 9 years old. And the final filter showing the sections with the surface age greater than 9 years, as shown by yellow, orange, and red lines. And we've come to the third critical role of integrated GIS maps, and that is to facilitate project planning and reporting. Here again, I will show examples from TxDOT, which uses a 4-year pavement management plan. TxDOT 4-year pavement management plan is very rigorous, and GIS maps are a big part of the process. The plan includes 4 years of construction projects and maintenance projects. The maps can display a wide range of information, including routine maintenance, preventive maintenance, and rehabilitation projects, as well as pavement condition and surface age. The different layers can be turned on and off to display different combination of data for project planning purposes. On the map shown here, I've turned on the layers to display rehab and preventive maintenance projects for the years 2019 and 2020 in this district. 2019 projects are shown by the X's, and 2020 projects are shown by the plus signs. Texas has 25 districts, and every district must present its 4-year plan each year for review by senior TxDOT officials. During the review, district officials use the GIS map like this one to present their plans to a committee of senior administrators. As you can see, the maps are effective of conveying information quickly in a way that is easy for non-technical audience to understand and is also easy for technical audience. So maps are both a powerful planning tool and a persuasive reporting tool. But most important is that maps are critical in helping the district teams create 4-year plans that deliver the positive impact from pavement management. Imagine the review team trying to sift through tables and planned M&T and rehab projects, trying to identify where the projects are and the type of work. Here is an example of a 4-year plan in action, where we see the rehab and preventive maintenance projects for the year 2022 shown by the red dots and the year 2023 shown by the light orange dots. So again, we have a single image that doubles as a powerful tool for planning and a compelling tool for reporting. The maps are printed and posted on the walls of TxDOT area offices and maintenance sections to help all the staff visualize all the upcoming projects to implement effective pavement lifecycle management. And remember, the impact of pavement lifecycle management is to identify the best mix of projects to meet the agency's goals of maximizing network performance, optimizing asset life cycles, meeting regulatory standards, and making the most of the budget by optimally allocating taxpayer dollars while preserving the value of the assets. Once again, my longtime former colleague, Dr. Jenny Lee from TxDOT, said it well. We use the 4-year pavement management plan as a reporting tool to improve visibility and accountability when briefing elected officials. Not only do the map-based 4-year plan support best practices internally, but they also improve communication with external stakeholders, and that leads me to the final section of my presentation. The benefits of using maps for pavement management. We've seen that maps serve to visualize many types of data, support spatial analysis, and facilitate project planning and reporting. But maps do more than that at the organization level for the agency as a whole. They improve data accessibility by providing a quick, easy, and efficient way of sharing information. They also improve organizational communication because every district uses maps to show senior administrative official the state of the roads in their district. Maps also improve cross-team collaboration because the district operations team share them with maintenance supervisors to help address immediate maintenance needs in a reactive manner, in addition to using maps in a proactive approach to plan upcoming projects. And this leads to greater operational efficiency, as maps are a centerpiece of the 4-year pavement management plan process, helping the agency save time and streamline workflows that impact multiple areas across the organization. Ultimately, maps makes it possible to implement effective pavement lifecycle management and to meet the agency key goals to maximize budget, optimize asset life cycles, meet regulatory standards, and improve network performance. No matter what the size of your agency and your road network, your agency too can adopt these practices and reap the benefits of effective pavement life cycle management. And with that, I'll turn it back to you, Terry, and I will welcome your questions.
Okay, thank you, Magdy. That was great. Okay, we will open the questions. You can type your questions into the question box, and we'll start answering them as they come in. Magdy, to start off, there was one questioner wanted to know about the ability to illustrate the data really lane by lane. So if I have a 4-lane highway, not all lanes will the pavement condition be the same. Do you have the ability to display by lane or by carriageway?
I think if you have by lane, it can be displayed, but you have to do some offset, artificial offset, so that you can see the lanes on the map. Actually, at TxDOT, we display it by road bed. So on our major corridors, we display the condition on the northbound and on the southbound for both main lanes and frontage roads. So it can be done.
Right. Yeah, and I guess I would reinforce that. It is typically when you're going to take a look at a section of roadway, then you're really zoomed in at an appropriate level. And in fact, as you say, offsets are one way in which you really can illustrate that. We have another question, and how do you see this integration of pavement management and GIS supporting the TAMP, the asset management plan?
I think it can definitely be helpful. I think you can show the planned project and planned activities for the national highway system, and you can also display the condition of the national highway system in your state or in your municipality or city or county.
Okay. Let's see. And can you speak a little bit to the integration of the Agile assets together with roads and highways, the Esri solution for managing the linear referencing?
I know we have the integration, and I think it can be used for the linear referencing system that you can use for the data collection and that you can use for mapping purposes. I know within the AgileAssets system, you can kind of generate the shape files and create the layers and display the maps. And also within the AgileAssets system and also within Esri, you can update your linear referencing system.
Okay, so and yeah, we probably don't want to get this bogged down too much into the minutia of linear referencing, but there's another question. Can you talk a bit about the implication of using linear referencing versus using coordinate-based systems, i.e. X, Y, and so at TxDOT, I assume, as a matter of fact, you did use linear referencing quite extensively. Can you speak to that a little bit?
Yes, I think the system can accommodate different referencing system. So we use the Texas reference marker system, but we can also use DFOs, and we can also use control section. So I think the system can accommodate different types or different ways.
Okay. And let's see, there's another question. What types of GIS analysis is performed other than just filtering the data? So maybe you could speak to, I know that, obviously it's very effective for presenting to senior management and elected officials, but could you maybe talk about the other types of GIS analysis? What insights were you able to see by using the GIS that maybe you would not have been able if you were just going through tables? Or
I think you can kind of display multiple layers on the same map. So for example, for the 4-year plan, we had a layer on the condition, and on top of the condition we were showing the planned project. So that helped us see where the planned activities as it relates to the condition of the roads. And also we're able to kind of also display the planned projects for multiple years. So now I know the planned activities, like how the projects are changing with time, and also how the project as they correlate to the current condition.
okay. Another question, how easy is it to integrate data from different systems? So to get data for other assets like structures that may be held in another system that's not in the pavement management system. So can you speak to that a little bit?
Well, if you're using an asset management enterprise solution, all those modules will use the same linear referencing system. So that will simplify the problem or eliminate the problem.
Okay. And let's see. So and again, within the GIS, obviously, the beauty is, yes, that in fact you may want to show, as often done, pavement condition together with a safety analysis, so that before you recondition a section, you really want to take a look and really do the safety analysis. So that is sort of the beauty of GIS, is the ability to bring together those different data from different sources and actually see it in the same experience. So another question, what's the experience in using GIS tools to perform the distress analysis and PCI calculations? Do you do that in the GIS, or do you do that in the AgileAssets pavement system?
No, we have it created in the Agile Asset System where we display our condition score, which is kind of a different kind of index equivalent to the PCI. So if you have the data and you have the georeferencing for this condition data, we're able to generate the maps for the PCI or our condition index.
Okay, all right. And let's see, there was a question in terms of, so everything that you were showing was really coming out of both Esri and then AgileAssets. So there's no other software that you're using currently to in the analysis that you were showing?
That's correct. That's
Yeah.
correct.
Okay. All right. So, you know, obviously within pavement management, there are different types of measures. So there's PCI, there's IRI, you talk about a condition index. Can you speak a little bit to the differences between those differences?
Yes. So, the PCI is a measure of overall pavement condition. Most states use different indices to represent the overall condition. So at TxDOT, we use the condition score that I showed in my presentation, which is a function of the surface distresses and ride. The IRI, which stands for the International Roughness Index, is a measure of smoothness. And actually, the ride score that I showed is a function of the IRI. It's calculated from the IRI. And we can generate maps within the system. And actually, we have maps that shows also the IRI. There was so many maps that can be generated for every individual distresses or every index that can be generated. So I only showed a sample. So, but I hope I answered the question.
Yes, yeah, no, you did. So, all right, we'll let give people a little bit of a chance to ask any other questions, but obviously this was a great presentation, Magdy, and certainly for those who are involved in pavement management, it seems to me, just to reinforce your point, I'm not sure how you can actually do good pavement management without GIS. To me, they go hand in hand. So, all right, another question is the pavement deterioration model developed and run in the Agile management system or in Esri?
No, it's in the AgileAssets system.
Okay, all right, and and you have different ways of calculating those deterioration curves. Is that correct?
Yes, you can. There are different ways of modeling deterioration. Can be done linear or sigmoidal or a combination of both.
Okay. And I guess another similar or any of the capabilities of ArcGIS used for modeling. So, for example, severe weather impacts to the roads and the use of the roads. Can you speak to that a little bit?
Yes, these factors are considered in the models developed, and actually in the TxDOT pavement management system, there are several thousands of models that are function of the different pavement types, the different truck traffic groups, and environmental regions, and also the kind of subgrade conditions.
Right. One of the things that certainly we have talked about here at Esri is, the ability to use big data techniques to look at 20, 30 years worth of pavement data and, integrating that with obviously not just the sort of standard, sort of soil type and so forth, but weather, volumes, and how do you bring all of that data together in a way that really perhaps allows you to really get to the next generation of degradation curves. And so have you begun to look at doing some of those types of analyses at AgileAssets?
We use our historical data to develop the models. TxDOT has more than 20 years of historical data, so that's what we used for developing the models.
Okay. And so the question, did the GIS data integration support the development of performance models or decision trees?
Yeah, I think, it can be, yes, we can generate maps that shows the recommended treatments by the decision tree. So you can generate a map that will show that this section of this roadway needs nothing, or this section needs PM or rehab or replacement. Maps can be generated from the outcomes of decision trees. And also you can also generate maps from the predictions, but it needs to be set up.
Okay. And then there's a question about have the ability to bring in LiDAR or large point clouds in GIS, and I can speak to that as well as you can. Do you use LiDAR or in your analysis?
TxDOT does not use LiDAR, but we can bring Esri layers into AgileAssets Pavement Analyst. Right. And that's what we also use at TxDOT.
Right. So, and I'm presuming, sort of the best practice is really the Pavemetrics lasers. Did you? How did you collect your pavement data at TxDOT, Magdy?
We had a contract with a service provider, Pathway Services, that collects the data for the whole state.
Right. Okay. All right. And let's see. There's a question about does the application include any prioritization to select optimal conservation strategies?
Yes, the system uses true optimization, where you define an objective function, like trying to maximize the performance, and your constraint is the available funds or the budget. And based on this analysis, the system will recommend an optimized work plan, and this work plan can be a multi-year work plan.
Okay. And there was a question, by the way, this webinar, if you came late or you weren't able to catch the whole thing, both the slides as well as the webinar will be posted. They'll be up on our website, the webinar in a couple of days in the normal spot. So if you just search for Esri Transportation Webinars, you'll be able to get to it. And then all of the slides will actually be in the GeoNet Departments of Transportation website. So we do want to, if you would like other colleagues to listen, or again, if you weren't able to catch the whole thing. And then another question, aside from visualizing the pavement condition scores, how are you using GIS to bridge the gap between pavement management and the causation of the distress? So really looking at and understanding what are causing the distress.
I think, for example, for me at TxDOT, I generated maps for the scores. And when I generated maps for the scores, after that, when sections that had low scores, we dig deeper. Then we generate map reports for the individual surface distresses. So I will know that the rutting or the cracking or the roughness is what's causing the overall score to go down. Then you go next then you look at your truck traffic, and from the truck traffic you see, oh, maybe I'm seeing an increased loading on these sections, that's why the pavement is deteriorating. Or I may look at the surface width to see maybe those are narrow lanes, that's why I'm getting a lot of edge failures. So you can keep drilling down to find out what's causing the distresses.
Okay, and so let's see if we have any more coming in. Well, I think that finishes, let's see, yeah, so that finishes our questions. Magdy, I'd like to thank you and AgileAssets for joining today. This was greatly informative, and again, this will be posted on our website, so you'll be able to again revisit the webinar if you were not able to catch it. So with that, Magdy, thanks again, and thank you all for attending today. And we'll see you next month for another in a series of webinars for departments of transportation. Okay, thank you. Bye-bye.